welcome to digital lesson. In this session we are going to learn tangents and secants part 2. In the previous class we have discussed definition of tangent and secant to a circle, construction of tangent to a circle, and also we have discussed construction of the pair of tangents from an external point. By the end of the session you will learn theorems related to the tangent and secants, segments of a circle formed by a secant, and also area of sector, area of minor and major segment of a circle, shaded region and unshaded region related problems. Let us see the first theorem. The center of a circle lies on the bisector of the angle between two tangents drawn from a point outside it. Let us see the diagram. So, this is a circle and a point P is outside the circle. From point P, two tangents drawn, and we know that two tangents are equal, that is PQ and P are equal. Suppose if we draw the angle bisector of this P, then this line always passes through the center of the circle. So, the center of circle lies on the bisector of angle. This is the bisector angle between two tangents drawn from a point outside it. Let us see the theorem was, let PQ and QR two tangents drawn a point, join OQ here, OQ and OR, then OQR and OPR are two triangles. So, if you observe that OQP and ORP is equal, which is equal to 90 degrees. So, we can prove that these two triangles are congruent triangle, right, because this is radius, equal radius of same circle, and these two also equal, so that we can say two triangles are congruent to each other. Then we can say OPQ is equal to OPR by corresponding parts of congruent triangle. Therefore, OP is the, here observe here, OP is the bisector of angle QPR. So, QPR, this is the total, QPR is nothing but angle P is a bisector of OP. Now, if you observe, hence the center lies on bisector of the angle between the two tangent. So, this is the one angle, say this angle is x, and this is the one more angle, this is also equal. Suppose total angle is 2x, this line divides two equal angles, that is x and x, and this line always passes through the center of the circle. Next theorem. In two concentric circles, the chord of the bigger circle that touches the smaller circle is bisected at the point of contact with the smaller circle. So, if you observe the figure here, one bigger circle and one smaller circle. So, this is the line AB, which is a chord to the bigger circle and tangent to the smaller circle. Now, we need to show that AP is equal to PB. So, if two concentric circle, the chord of the bigger circle that touches the smaller circle is bisected at the point of contact with the smaller circle. Let us see once proof of this. Consider two concentric circles C1 and C2 with center O, and a chord AB of the larger circle C1 touching the smaller circle C2 at the point P, which is the point of contact. Now, we need to prove that AP is equal to PB. That means OP is bisecting the AB. So, for that, first join OP, this is the OP, and also AB is a tangent to circle C2 at P, and OP is its radius. Therefore, OP is perpendicular to AB. We know that the tangent at any point of a circle is perpendicular to the radius through the point of contact. So, the angle at point of contact is always 90 degrees. So, we can say OP is perpendicular to AB. Now, there are two triangles formed, OAP and OPB, and we can say that these two triangles are congruent triangle because OA and OB are radii of the same circle, and also OP is a same side, OP is equal to OP we can say. So, these two triangles are congruent to each other. So, by CPCT we can say AP is equal to PB. If two triangles are congruent, we can say AP is equal to PB. Therefore, OP is the bisector of the chord AB as the perpendicular from the center bisects the chord. Now, let us see theorem number 3. If two tangents AP and AQ are drawn to a circle with center O from an external point A, then angle QAP is equal to 2 angle QPO, or else is equal to 2 times of angle OQP. Just observe the figure, students. If two tangents, so observe here, AP and AQ both are tangents drawn from an external point, and we know that AP and AQ are equal because two tangents drawn from an external points are always equal. So, angle theta is an angle between PAQ. Let us prove this. We are given a circle with center O, an external point A, and two tangents AP and AQ to the circle where PQ are the points of contacts. So, P and Q are both point of contacts, and we know that at point of contact with the radius the angle is 90 degrees. So, this angle will be 90 degrees, and at Q also with radius angle is 90 degrees. We need to prove that angle QAP is equal to 2 times of angle QPO or 2 times of angle PQO. Let angle QAP is equal to theta. Here observe here, this is, suppose I am taking it as theta. Then what we need to show? I need to show this is a theta by 2 and this also theta by 2. We know AP is equal to AQ. This AP and AQ are equal. Why they are equal? Because the lengths of tangents drawn from an external point of a circle are equal. So, triangle, then APQ is a triangle which is a isosceles triangle. Why it is isosceles triangle? Because AP and AQ both are equal. So, I can say if two sides are equal, then their opposite angles also equal. I can say APQ and AQP are equal. APQ or PQA are equal. Therefore, we know the one theorem. What is that? The sum of angles in a triangle are always 180 degrees. So, APQ is a triangle where sum of angle APQ plus PQA plus QAP is equal to 180 degrees. Sum of three angles are always 180 degrees in a triangle. Now, angle QAP is equal to theta. I have supposed it. So, I am substituting here angle QAP theta. Then it becomes APQ plus PQA plus theta is equal to 180 degrees. Now, APQ, PQA both are same only. So, APQ is equal to PQA both are same. Then I can write 2APQ plus theta is equal to 180 degrees. 2APQ plus theta is equal to 180 degrees, which I can write 2APQ is equal to 180 minus theta. 180 minus theta, I am sending theta to this side, right hand side, then 180 minus theta. So, I can write 2APQ is equal to 180 minus theta, that means APQ is equal to 90 minus 1 by 2 into theta. So, 180 minus theta by 2, I can write 180 by 2 is 90 degrees and theta by 2 is, I can write as 1 by 2 into theta. So, APQ I got it as 90 minus 1 by 2 theta. Now, OPA is equal to 90. How OPA is 90? Because OPA is an angle at point of contact, right? We know that angle at point of contact with radius is always 90 degrees. So, we can say OPA is equal to 90 degrees. So, OPQ is equal to, I can write total angle minus APQ. This total angle minus APQ, I will get it as OPQ. So, I can write OPQ is equal to OPA minus APQ. So, what is OPA? OPA I got from equation 2, 90 minus APQ is 90 minus 1 by 2 theta. So, if I divided it, 90 minus 90 minus into minus plus 1 by 2 theta. So, 90 can be cancelled. So, finally, I am getting OPQ as 1 by 2 into theta. So, what is theta here? Theta is angle APQ. So, we know that angle QAP is equal to theta. If I substitute here 1 by 2 into angle of QAP. So, which is equal to angle OPQ. So, OPQ is equal to half of QAP, which I can write as 2OPQ is equal to angle QAP. Also I can write both are equal only, so I can write angle QAP is equal to 2 into QPO is equal to 2 into OQP. Next let us see segment of a circle formed by a secant. So for a circle and also a secant. By the secant, how many segments will be formed? Let us see now. This is a circle. Let us see now. A secant is a line which intersects the circle at two distinct points, and the line segment between the point is chord. Here L is the secant and PQ is the chord. What is segment? A segment is a region bounded by an arc and a chord. There are three types of segments can be formed. One is a minor segment, one is a semicircular segment, and one is a major segment. Now let us see how to find the area of segment of a circle. See this figure now, circle and a secant. So what is a minor segment? The area enclosed by a chord and a minor arc. The area enclosed by a chord and minor arc is called minor segment. Now this is a semicircular segment. What is a semicircular segment? The area enclosed by a chord and semicircular arc. And the third one is a major segment. So what is a major segment? The area enclosed by a chord and major arc is called major segment. Now let us see what is a sector. Students, you have already learned in the previous class what is a sector, how to find the area of sector and all. Let us quickly recap this. Sector is nothing but the area enclosed between two radius and the arc. So we can say this is a circle, OA is a radius and OB is a radius, then two sectors formed, one is a minor sector and one is a major sector, and OA and OB are radius. So the area enclosed by an arc and the two radii is called a sector. If the arc is minor arc, then the sector is called minor sector. If the arc is major arc, then the sector is called major sector. Now let us see area of sector formula. So already we have studied in the previous class. Area of sector is equal to x by 360 into pi r square. X by 360 into pi r square. What is x here? X is angle between two radii here. X by 360 into pi r square, and pi value we can take it as 22 by 7 or 3.14, and r is the radius of circle. Find the area of sector whose radius is 7 with the 60-degree angle. So this is the circle, OA, OB is a radius and OAB is a minor sector. Now how to find the area of this sector? Given angle is 60 degrees and given r is equal to 7 and x degrees is equal to 60. Now we know the formula area of sector. What is the area of sector formula? Is x by 360 into pi r square. Area of sector is equal to, substitute the values, x is equal to 60 by 360 into pi is nothing but 22 by 7, r is 7 into 7. Now I can cancel 60 ones are 60, 60 6 are 360, also 7 ones are 7 ones are. So I can multiply 22 into 7, 1 by 6 into 22 into 7 will be 154. So if I cancel 6 ones are 6 twos are 6 fives are 0.666 are. So that means 25.66 is an area of sector where the angle between two radii are 60 degrees. So therefore the area of sector is equal to 25.66 square centimeter. Now let us see second problem. The length of minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 10 minutes. That means this is a clock and this is a minute hand, and which is started from here and it came till 10 minutes. So what is the angle between these two? And if you observe, this is a sector, right? So to find the area swept by the minute hand is nothing but area of sector, and the radius is nothing but the length of the minute hand. Given r is equal to 14, x is equal to angle made by minute hand in 10 minutes. So we know that total angle is 360 for 60 minutes. So if a minute hand is starting from here and coming back here, means totally it will make 360 degrees. So, if 360 degrees for 60 minutes, then what is the angle for 1 minute? For 1 minute the angle is 6 degrees. So, for minute hand making 6 degrees angle for every minute. So, I can say here 10 minutes the angle is 60 degrees. Now, given r is 14 and x is equal to 60 degrees, area of sector is equal to x by 360 into pi r square, and x is nothing but what we got here, 60 degrees. 60 by 360 into 22 by 7 into r is given as 14 into 14. 60 ones are 66 are 7 ones are 7 twos are. Now, if you multiply this, then you will get the answer as 1 by 6 into 22 by 14 into 2 is 28. So, if you multiply total this, 22 into 28 is 616 by 6, which is equal to 102.66 square units. So, this is the way to find out the area of sector. Now, let us see area of minor segment. How to find the minor segment area? Observe the figure, students. Here this is a circle and AB is a chord. What do we call this shaded part of the circle? We call it as minor segment of a circle. So, this we call it as minor segment of a circle. Same way, what do we call this unshaded parts? So, shaded part we call it as minor segment. What do we call this unshaded part? So, unshaded part we call it as major segment of circle. Therefore, APB is a minor segment and AQB is a major segment. The portion of some unshaded part and shaded part is a sector. Let us see now. Here sector is the combination of a triangle and a segment. So, this is a triangle and minor segment in this case. Let OAPB is a sector of a circle with center O and radius R. Let the measure of AO be x. Here x is there. This is the angle of sector. Then area of the minor segment APB is equal to, I can say, the total area of sector OAPB minus area of triangle OAB. Now, what is the area of sector? Area of sector is x by 360 into pi r square minus area of triangle OAB. Area of major segment. Finding the area of major segment using area of the corresponding minor segment. If you know the area of corresponding minor segment, how to find the area of major segment? Instead of using total formula, we can use to find out the area of major segment. If you know the minor segment, simply the area of total circle minus area of minor segment, if we do, we will get the area of major segment. So, finding the area of major segment using area of the corresponding minor segment. Area of the major segment AQB is equal to area of the circle minus area of minor segment APB. So, area of the circle formula is pi r square minus area of minor segment. Now, let us see some problems based on this. Find the area of the segment if PQ is equal to 24, PR is equal to 7 and QR is the diameter of the circle with center O. Let us solve this. Solution: given PQ is equal to 24 and PR is equal to 7. Here QR is a diameter, then QPR is equal to 90 degrees. Why QPR is equal to 90 degrees? Because it is a angle in a semicircle. So, always angle in semicircle is 90 degrees. So, now we will find out using Pythagoras theorem in the triangle PQR, QR square is equal to PQ square plus PR square. QR square is equal to PQ square plus PR square. QR square is equal to 24 square plus 7 square. This is 24 and this is 7. 576 plus 49, which we can find it as QR square is equal to 625 and QR is equal to 25. So, we know the diameter now. Diameter is QR 25. Then what is the radius? Radius is 25 by 2, that is QR is equal to 25, since QR is the diameter, radius R is equal to 25/2. Area of the minor segment is equal to area of sector OQPR minus area of triangle PQR. So, here sector is a semicircle. Now, area of a sector OQPR, sector is a semicircle. Now, let us find area of sector and area of triangle. So, area of semicircle is equal to half into pi r square. Area of circle formula is pi r square, area of semicircle is half into pi r square. Now, let us substitute 1/2 into pi is 22/7, r is 25/2 into 25/2. If you simplify this, you will get the answer as 245.53 centimeter square. So, we got now area of semicircle, which is 245.53 centimeter square. Now, we need to find out area of the triangle PQR. So, half into base into height. This is a right angle triangle, right? So, right angle triangle, we know the formula half into base into height. Here base is PQ and height is PR. So, we know the value of PQ and PR, half into 24 into 7. So, 2 1s are 2 12s are, so 12 7s are 84. Now, we got the values of semicircle and also we got the value of area of triangle. Now, how to find the area of minor segment? Area of minor segment is equal to area of sector OQPR minus area of triangle PQR. So, we got area of sector OQPR is 245.53 and area of triangle as 84. If you subtract this 245.53 minus 84, you will get it as 161.53 centimeter square. So, therefore, area of the shaded region is 161.53 centimeter square. Now, let us see one more problem. Find the area of shaded region in figure if ABCD is a square of side 7 centimeter and APD, BPC are semicircle. Now, let us solve this. Given CD is equal to 7 centimeter, which is a length of the side of square. R is equal to 7/2. Why we got R as 7/2? Because total, this is the diameter, diameter is 7, so radius will be half of the diameter, which is R is equal to 7/2. ABCD is a square and APD and BPC are semicircles. Area of the shaded region is equal to area of a square ABCD minus area of two semicircles. So, area of square ABCD and area of two semicircles. We know that area of a square formula which is a side into side, and area of two semicircles is nothing but area of one circle, that is a pi r square. Now, let us substitute the values here. Area of a square is s into s minus 2 into area of two semicircle is half into pi r square. 2 cancel, 7 into 7 minus 22/7, pi value 22/7 and r is 7/2 into 7/2. 7 can be cancelled and 2 1s are 2 11s are. So, 7 7s are 49 minus 77/2, which is equal to 49 minus 38.5. 49 minus 38.5 will be 10.5 square centimeter. So, therefore, area of the shaded region is equal to 10.5 square centimeter. Students, try yourself this problem. Find the area of shaded region in the adjacent figure where ABCD is a square of side 10 centimeter and semicircles are drawn with each side of the square as diameter. So, this is the figure, students. You try yourself. And the second problem, calculate the area of designed region in the figure common between the two quadrants of the circle of radius 10 centimeter each. So, this is the square and this is a sector and this is also a sector. Using the formula, you can solve this problem. So, what we have learned, students, today? We have learned some theorems related to tangent and secants, and also we have learned segment of a circle formed by secant, and we have learned area of minor segment and major segment and the problems related to major segment and minor segment, and also the problems related to shaded region and unshaded region. For the better understanding of the concepts, solve the worksheets, please visit the official website of SCRT for worksheet. Thank you very much, students.